Imagine two AIs, right?
Yeah.
Perfectly mimicking the communication styles of you and your boss. And they're just negotiating your next promotion while you both sleep.
Right, yeah. Which sounds completely crazy.
It sounds like a speculative sci-fi novel. But, I mean, based on the stack of research sitting in front of us today, and let's go ahead and timestamp this, we are analyzing the AI landscape as of July 18th, 2026.
Yep.
The infrastructure for that exact reality just went live. So, welcome to today's deep dive. We're thrilled to have you with us.
Glad to be here.
So our mission today, for you listening, is to connect the dots of this incredibly rapidly accelerating tech ecosystem. We're looking at a sweeping architecture here. You know, the core software brains, the underlying hardware brawn.
Right, the physical side of it.
Exactly. And the invisible integration into our daily work, the really high-stakes applications in medicine, and the new frameworks attempting to govern the entire machine.
Which is a tall order.
It is. But by the end of this conversation, you'll see how these seemingly isolated updates paint one complete unified picture of where we are right now. Okay, let's unpack this.
Yeah, and it really is a profound moment to be analyzing this space. I mean, we aren't just looking at incremental software updates anymore, you know.
Like bug fixes and stuff.
Exactly. We are watching a fundamental shift in both the capability of the technology and really the societal architecture required to sustain it. How we innovate, how we heal, how we collaborate. It's all being rewritten simultaneously.
Yeah. And I want to start right at the foundation of that capability, you know, the updated brain of the operation. OpenAI just unveiled GPT-4.5.
Huge news.
Massive. And the immediate headline everyone is talking about is its enhanced language processing.
Yeah.
You know, the generation of highly sophisticated, really human-like text.
Right.
But looking past the surface, the crucial evolution here is what they're calling improved contextual awareness.
Yes. That's the real game changer.
Right. It's this ability to maintain coherence over incredibly long, complex interactions. I'm trying to visualize the underlying mechanism here because, I mean, interacting with earlier generation models often felt like working with someone who had like a severe short-term memory deficit.
Yeah, that's a really good way to put it.
You know,
Yeah.
like you'd establish a complex premise and maybe 20 prompts later, the model would just hallucinate or completely lose the plot. And you'd have to rebuild the context from scratch.
Right. And that limitation was essentially a bottleneck in the model's architecture, specifically its context window.
Okay, break that down for us.
So earlier models could only hold a limited number of tokens. Think of tokens as like word fragments. They could only hold so many in their active memory before old information was just pushed out to make room for new inputs.
Oh, like a conveyor belt falling off the edge.
Exactly. What GPT 4.5 represents is a massive expansion of that architecture combined with far more sophisticated retrieval mechanisms. It isn't just remembering better, you know?
Okay, so what is it doing?
It's dynamically mapping the entire history of a conversation in this multidimensional vector space, which allows it to pull relevant threads from hours or, I mean, even days ago with high precision.
Oh, wow. So instead of a simple linear memory, it's building like a web of our interaction.
Precisely.
It's less like a basic search engine interface and more like, I don't know, bringing a new developer onto a complex coding project.
Yeah, that's a perfect analogy.
Right, like you explain the architecture on Monday, and by Thursday, they don't need you to re-explain the foundational logic before they write a new function. They just build on what was already established.
What's fascinating here is how that single structural upgrade fundamentally changes the utility of the AI.
How so?
Well, when a model suffers from context decay, like we were just talking about, it operates as a transactional vending machine.
You put a coin in, you get a snack out.
Right. You put a highly specific query in, you get a localized answer out, and the engagement ends. But introducing long-form coherence shifts that dynamic entirely.
It becomes continuous.
Exactly. The AI transitions from a utility to a sustained collaborative partner. For developers, data scientists, or, financial analysts, this means you can feed the model multi-step, deeply layered projects.
Right.
It can evaluate code, analyze a subsequent data set, and reference the original code's constraints without ever losing the thread. It essentially becomes a persistent digital colleague.
A persistent digital colleague. That tracks. But, this brings up a logistical hurdle that I just can't quite wrap my head around.
Which is?
Well, expanding a context window to that degree, mapping all those complex interactions in real time, that requires an absolutely staggering amount of compute.
Oh, yeah. Massive.
How does a model process that much layered context so quickly without the latency making the whole experience just unbearable for the user.
Well, it requires serious, dedicated muscle. The software evolution is entirely dependent on the hardware catching up.
Which flows perfectly into the NVIDIA announcement we've got here.
Yes,
Yep.
exactly.
So they've just unveiled a new suite of AI-focused architecture designed explicitly to accelerate these massive machine learning tasks.
Right.
And the data indicates unprecedented computational power. But the metric that really stands out to me is a radical reduction in training times for complex models.
That's the key.
But I want to push back on this for a second, and just on behalf of the listener. When we hear about faster silicon, the consumer translation is usually, oh, cool, my rendering software won't lag, or my database queries run a fraction of a second faster.
Right. We think of it in terms of our daily convenience.
Exactly. So does slashing the training time of a massive AI model actually change what researchers can build, or does it just change when they deliver the exact same product to the market?
That distinction is everything, actually, and it's a very common misconception. We tend to view computational speed purely as a measure of efficiency, just saving time.
Right, getting the same thing, just sooner.
Yeah. But if we connect this to the bigger picture, we have to look at the scientific concept of iteration. Progress in machine learning is heavily bottlenecked by how quickly a researcher can test a hypothesis.
Because training a model from scratch is basically a giant trial and error process.
Exactly. Let's say an AI lab has a brilliant theoretical idea for a new neural network architecture. Maybe one designed for advanced climate modeling, rather.
Right, tracking.
But their current hardware infrastructure dictates that training this model will take 6 months.
Wow, just to train it once.
Right. That means they get to run their experiment, tweak their hyperparameters, and see if the theory actually works maybe twice a year.
Right.
That's 2 iterations, 2 chances to learn from a failure.
Wow. So if the model collapses or, I don't know, the data was poorly weighted, half of their funding year is just gone. Poof.
Precisely. Now imagine NVIDIA's new architecture compresses that massive parallel processing workload, reducing that 6-month training cycle down to 6 days.
Wait, 6 days.
Yes. You aren't just getting the same climate model faster, you are altering the fundamental fabric of how innovation occurs.
Oh, I see.
The lab can now test 50 different architectural theories a year instead of 2.
That is insane.
The speed of trial and error, of discarding dead ends and refining successful neural pathways, goes into absolute hyperdrive. And when you apply that compounding speed of iteration to material science, to logistics, to genomic sequencing, it sets a completely new baseline for human discovery.
Wow.
It's not just speed. It's the sheer volume of innovation that speed unlocks.
Okay, that completely reframes it for me. It's not just making the car drive faster. It's building a factory that lets you design, crash test, and refine an entirely new type of engine every single week.
Exactly.
But that kind of brute force computational power isn't just staying locked in a server farm or university lab, is it? It invariably compresses and filters down to the consumer applications we use every day.
It does, yeah. And often in ways that are deliberately designed to be invisible to us.
Which brings us to Google's rollout of their new Smart Compose AI across the Workspace suite. Now, basic predictive text has been around for years.
Oh, sure.
But the documentation here shows a massive leap in capability. By leveraging these advanced natural language processing models, this system isn't just guessing your next word based on common grammar.
Right.
It predicts and suggests entire complex phrases as you type.
Wow.
And the feedback from the early deployment emphasizes how flawlessly it adapts to an individual's highly specific writing style.
Yeah, it's a localized, highly personalized application of the exact same mechanisms driving the larger models we just talked about.
I was actually trying to find the right analogy for this. It's not just a ghostwriter. It's more like a master musician who has studied your specific sheet music for years.
Oh, I like that.
Right. It understands your vocabulary, your specific cadence, whether you use formal transitions or casual phrasing. And it can anticipate your next chord progression before your fingers even hit the keyboard. But how is it doing that locally without hallucinating or defaulting to that, that super generic corporate tone we all know?
Well, it comes down to mathematical embeddings. The AI isn't reading your previous emails the way a human does. It's creating a vast topological map of your language.
A map of my language.
Yeah. It measures the vector distance between the words you frequently use in specific contexts. So if you consistently use a certain phrase when addressing your marketing team, the model maps that probability.
Okay, so it's math, not comprehension.
Right. Over time, it builds a highly accurate mathematical representation of your specific voice. But what's significant about this release isn't just the accuracy, it's the psychological shift in how we interact with the technology.
What do you mean by psychological shift?
Well, for a long time, engaging with AI was an intentional destination.
Right, you had to go to a separate tab.
Exactly. You had to navigate to a specific website, open a distinct interface, and explicitly prompt a system to perform a task. What Google is doing with Smart Compose is turning AI into an invisible environment.
Oh, an environment. I see.
Millions of people will be drafting complex reports, organizing logistics, and managing their communications with vastly improved efficiency without ever feeling like they are using AI. The friction of the interface disappears, and all that's left is just enhanced human output.
AI as an environment. That is a brilliant way to conceptualize it. But, predicting the syntax of a quarterly earnings email, while technologically impressive, is still applying pattern recognition to relatively low-stakes environments.
Sure.
What happens when we take that exact same core mechanism, the ability to map and recognize incredibly subtle, complex patterns, and apply it to data where the stakes are literal life and death?
Then we move from augmenting productivity to fundamentally altering biological outcomes.
Which takes us to the breakthrough from a coalition of university researchers who have developed a new AI-powered diagnostic tool for cancer detection.
This is truly incredible stuff.
It is. They're utilizing deep learning algorithms to process raw medical imaging data. But here's where it gets really interesting. The documentation specifically emphasizes that this tool is identifying early localized signs of cancer with precision that is frequently missed by the human eye.
Yes.
I want to pause on the mechanics of that.
Yeah.
We aren't just teaching a machine to do a human radiologist's job a little bit faster. We're teaching it to see what biological retinas are physically incapable of seeing.
That is the crucial distinction right there. When a human doctor looks at an MRI or a CT scan, they are constrained by the biological limits of the human eye's ability to differentiate shades of gray.
Right, we can only see so much contrast.
Exactly. And also the cognitive limits of human fatigue. But a deep learning model doesn't look at a picture. It analyzes a massive matrix of raw numerical data.
Oh, so it's just numbers to the AI.
Right. It can detect microgradient shifts in pixel density patterns of cellular abnormality across thousands of scans that are mathematically invisible to us.
So we are essentially giving the medical field superhuman vision. But that immediately triggers the anxiety we see across all sectors right now. Does a tool that can outperform a radiologist's visual accuracy replace the doctor?
This raises an important question, and it's the central debate within the medical community's integration of AI right now. The consensus, heavily supported by the framework of this new research, is that it doesn't replace the physician. It elevates the nature of the profession.
Elevates it how?
Think about it. If an algorithm takes over the raw, exhaustive, pixel-by-pixel pattern recognition, the human doctor is freed from the mechanics of detection.
Right.
Armed with earlier, vastly more accurate diagnostic insights, the physician can pivot entirely to complex, holistic decision-making.
Oh, so the doctor shifts from being a data processor to a strategist.
Exactly. They can take that early algorithmic diagnosis and cross-reference it with the patient's unique genetic history, their lifestyle constraints, and their psychological resilience to craft a highly personalized treatment protocol.
Because the AI can't do the human empathy part.
Right. By automating the visual analysis, we remove the robotic elements of the profession, allowing doctors to be more human, and profoundly improving long-term patient survival rates.
I mean, the beautifully optimistic view of the technology, but I think we need to ground this, because when you look at the sheer velocity of everything we've just discussed today,
It's moving fast.
yeah, GPT-4.5 holding sustained, complex context. NVIDIA hardware allowing massive models to iterate in days instead of months. Google algorithms mapping our personal psychology to write our emails, and deep learning systems making localized oncology diagnoses.
Right.
The potential for systemic failure scales up just as exponentially as the computing power.
Oh, for sure. Unintended consequences are always the shadow of rapid capability overhang. When the technology moves faster than the societal understanding of the technology, the friction points can be catastrophic.
Which brings us to the final piece of the ecosystem we are analyzing today, the governance. A new AI ethics and safety board has just been established. But the structural makeup is what stands out to me. It's not just a government committee. It's a formalized coalition between massive tech conglomerates and leading academic institutions.
Which is very unique.
Right, and their stated mandate is to create strict operational guidelines for responsible development anchored by three pillars: transparency, fairness, and accountability.
Hmm.
But I have to play the skeptic here.
Go for it.
We just spent 20 minutes dissecting how NVIDIA is putting iteration into hyperdrive. Can a bureaucratic ethics board realistically govern a technology that iterates in days? Aren't they just destined to be perpetually playing catch-up, writing regulations for models that are already 3 generations obsolete by the time the ink dries?
It is the defining governance challenge of our era, the pacing problem between algorithmic capability and regulatory oversight. And your skepticism is entirely warranted.
I mean, how could it not be?
Historically, we have seen two distinct failed models of governance in tech.
Let me guess. The tech companies grading their own homework, or the government writing rules for things they don't even understand.
Precisely. On one hand, relying purely on corporate self-regulation usually results in regulatory capture.
Right.
The financial incentives to deploy first and capture market share almost always override the theoretical incentives to move slowly and ensure complete safety.
Yeah, we've seen that movie before.
Exactly. On the other hand, you have academic ethicists or government regulators working in a theoretical vacuum, completely disconnected from the actual engineering pipeline.
So they write broad, sweeping rules that sound great in a congressional hearing, but are technologically impossible to implement at the code level.
You nailed it.
So why is this specific coalition supposed to be any different?
Because they are attempting to merge the pipeline. By legally binding the developers who are actually building the frontier models with the academic researchers who study the systemic societal impacts, they are trying to build the brakes into the engine design itself.
Okay, I'm trying to see how that works in practice, beyond just a slick PR statement.
Let's look at their 3 pillars. Transparency isn't just about publishing a white paper anymore. It's about open sourcing the training methodologies so third parties can actually audit how a model weighs decisions.
Okay, that's concrete.
Fairness is about ensuring the petabytes of training data aren't inherently perpetuating historical biases in things like, say, loan approvals or medical triage.
Right, because if the data is biased, the AI is biased.
Exactly. And accountability, which is the hardest one to enforce, honestly is about establishing a clear legal chain of liability when an autonomous agent inevitably makes a harmful error.
Yeah, who gets sued when the AI messes up?
Right. The goal of this coalition is to standardize these protocols before the next generation of hardware allows models to become fully agentic. It is a desperate but totally necessary attempt to ensure these advancements stabilize society rather than fracturing it.
So it's not just about writing rules.
Mhm.
It's about embedding the rules into the architecture before it scales. That actually makes a lot of sense.
Yeah, it's a structural approach.
Well, let's take a breath and look at the massive landscape we've mapped out today.
We covered a lot of ground.
We really did. We started with the foundational mind of GPT-4.5, expanding its context window to become a sustained digital collaborator. We saw how NVIDIA's new hardware architecture provides the sheer processing muscle required to compress innovation cycles from months into days.
Right.
We traced how that massive compute filters into our personal environments, allowing Google's Smart Compose to map our linguistic vectors and act as an invisible, assistive layer in our daily communication. We explored how those same pattern recognition mechanisms are revolutionizing oncology, reading microscopic biological data to elevate human doctors.
Yep.
And finally, we examined the complex cross-industry coalition desperately trying to build the ethical and operational guardrails required to keep this accelerating infrastructure from derailing.
It's all connected.
So what does this all mean? For you, the listener, trying to navigate this space can absolutely feel disorienting. I mean, the capabilities literally shift daily. But by looking past the isolated headlines and understanding the underlying mechanics, how the hardware enables the software, how the software alters our behavior, and how governance attempts to stabilize the resulting system, you are building a mental framework.
And that's vital.
Right. You aren't just reacting to tech news anymore. You are understanding the causal links of an entirely new ecosystem.
And, as you use that framework to observe the ecosystem this week, I want to leave you with one final thought, drawing directly on the specific capabilities we connected today.
Well, lay it on us.
We discussed Google's ability to map your vocabulary vectors and perfectly predict your specific voice, right?
Yeah.
And we explored GPT-4.5's massive context window, granting it the ability to hold long, highly nuanced, coherent conversations. Consider this scenario. In the very near future, you use your personalized AI to draft a complex, high-stakes email. Maybe it's a contract negotiation, and it's written in your exact cadence. You deploy it. The recipient receives it, and they use the personalized AI to analyze the context, synthesize a counterargument, and draft a response in their exact voice.
Oh boy.
What happens when two highly capable AIs, perfectly mimicking the psychology and syntax of their respective humans, end up negotiating, debating, or making binding agreements with each other on our behalf? At that point, who is actually having the conversation?
Oh, wow. A highly complex negotiation happening entirely between digital proxies, but resulting in real-world consequences for the humans sleeping in the other room.
Mhm.
That is a fascinating and, honestly, deeply unnerving paradigm shift.
It really is.
We'll let that aha moment marinate for a while. I want to thank you for joining us today and letting us help you map this architecture. Stay curious, keep exploring, and we'll see you next time for another deep dive.